Let's talk about the critical path method. The critical path method is one of two ways that you can, or one of two tools that you can use to identify the paths through your project. The other way is called PERT, Program Evaluation and Review Technique. The difference between critical path and PERT is that critical path uses one time estimate, whereas PERT uses 3 time estimates. So critical path is more or less for when you're pretty sure about the durations, the time it's going to take to do each task or each activity, whereas PERT is used in a more uncertain situation. You remember our discussion about uncertainty? And you can use these 3 time estimates to come up with something called the expected time. We're going to start with the critical path method since it is the simplest way. We're going to use a method that's a little different than in your book. We're going to use this key. This key, if you'll notice in the center block, that is that A represents activity, and down here D represents duration, whereas ES is early start, EF is early finish, LS late start, and LF late finish. Over here we're going to have S, which is equal to slack time. You'll notice this block right here where I have the diagonal lines. All that is a block where you can write a description in of the activity if you choose to do so. So let's get into the details of critical path. When you're using the critical path method, you need 3 pieces of information: activity, predecessor, and duration. You need to have the activities listed. You need to know which activities are predecessors to other activities, and then you need to know the time that each duration will take. In this instance, we're going to use weeks as our unit of time. So using this information, we can draw a precedence diagram. And if you look at the precedence diagram, you can see all of the paths that go through our project. And there are many different paths. This means that some activities can be done concurrently, simultaneously. Some activities, though, cannot be done that way. They have to have the previous activity completed before you can move on. And so this drawing, this precedence diagram, gives you a pictorial view of what the project should look like. We can use this diagram to go through and identify our tasks, or I'm sorry, our paths. For instance, we have paths A, C, F, and I. We have path A, D, H, and J, path A, D, G, and J, and path A, E, H, and J, B, F, and I. So we have 5 paths through this project. We can go through and we can use the information that we had for each one of these activities, and we can identify what the critical path is. So what is the critical path by definition? Well, if you'll remember in class, we talked about the critical path as being that path that if you had any delays on, it would delay the entire project. That means that there is 0 slack time associated with the critical path. Right now, all the information we want to know is which one is the critical path. So we can go through and we can add up each one of the activity times, and we can see that for our first path it's 18 weeks, second 19, third 18, fourth 21, and fifth is 14. So what does that mean to us? Well, what that means is that our critical path is A, E, H, J, because it takes 21 weeks. That's the longest duration of any path in our project. And what that means is that these activities are not going to have any slack time on them. And that is the path that we're going to monitor through our project. So we're going to use this and use my boxes now. And I've drawn out the network, and this is what it would look like with the boxes. So the first thing that we're going to do is we're going to do something called a backwards pass. Excuse me, we're going to do a forward pass. Okay? That means that we're going to move from left to right. In case y'all don't remember when you were in class, I told you I was dyslexic. Remember that. All right. So we're going to start with activity A. And if you remember, a starting activity begins at time 0. So our early start for activity A is going to be 0. The same thing for activity B, because if you remember on our information, activity B had no predecessors. Okay, so now we want to calculate what the early finish time is going to be. To calculate early finish, we're going to take early start and add the duration. So 0 plus 5. 0 plus 4. All right, so we've done the first 2 tasks. Now we're looking at this diagram and we see out of activity A that we have 3 arrows. We don't have to make any choice. We automatically know that the early start for each one of those activities is going to be 5. Again, we're going to calculate the early finish. 5 plus 3 is 8, 5 plus 4 is 9, 5 plus 6 is 11. Well, now we get into a little bit of a dilemma because we see all of these arrows going all different directions, so we sort it out. Okay, for activity F, right here, we have 2 activities that feed into it, C and B. We have to make a choice. You see that we have an early finish of 8 for activity C and an early finish of 4 for activity B. Remember by definition that the path, all of the activities have to be complete, all of the predecessor activities have to be complete before the new activity can begin. That means that we have to choose the highest of the 2. So we're going to choose 8 for our early start for activity F. For activity G, we only have 1 predecessor, which is D, so we don't have to make any choice. So for activity G, we're going to have 9 as our early start. For activity H, we have activity D and activity E that feed into H. So we have to look at those early finish times and we have to determine which one is going to be our early start for activity H. Activity D has a early finish of 9 and activity E has an early finish of 11. We're going to choose the higher of the 2, which is going to be 11. 11 plus 6 is 17, 9 plus 5 is 14, and 8 plus 4 is 12. So now we need to come over here to activity I. Activity I, we have no choice. We know our early start is 12. 12 plus 6 is 18. For activity J, we have to choose between the early finish for activity